Good afternoon, students. Good afternoon to one and all. Welcome you all for Prerana Day classes. Today class we will see about the structural analysis. In this structural analysis, we will see some basics about the GATE and then what are the tips that we have to follow for a GATE exams. It will be very useful for us to prepare for competitive exams. Okay. First of all, we will see some basic definitions of the structural analysis 1 and 2. Here we will know first of all what is meant by structure. Structure is nothing but it is an elastic body. If an elastic body is subjected to a system of forces, in last class in engineering mechanics we know what are the system of forces. There will be a number of system of forces are there, that is coplanar forces and collinear forces, concurrent, like that. Here also we will see if any body, if an elastic body is subjected to some system of forces, there will be some deformations will take place here, and the resistance offered by the body against the deformation, then the elastic body is known as a structure will called. Okay. If it is defined as the number of elements that is connected together to sustain a load, if no resistance offered by a body against the deformation, whatever the load is acting on the body, there is no deformation is occurred, that type of system is called as a mechanism here. Okay. Structure is nothing but there will be a number of system of forces is acting on that, and then some deformation takes place there. And then it will be offered some body against its deformation. There will be some deformation is there, but the body will against from the deformation, and then the elastic body is known as the structure here. Similarly, here you can observe that one. Next one is whatever the number of elements that are connected together to sustain a load, and then there is no resistance that will be offered by a body against its deformation will be called as the mechanism. Okay, next we will see structural analysis. What is the definition of the structural analysis? It is a mathematical algorithm process that by which the response of the structure to specified loads and actions is determined. That will be, there will be a number of loads that will be acting on a structure, like imposed load, dead load, live load, that has to be followed, and that whether it will be a column, beam, that all has to be defined by the mathematical algorithm process here. The response is measured by determining the internal forces or stresses, resultants, and the displacement or deformations throughout the structure, how it will be acting, that all we will find in the structural analysis. The structural analysis is based on engineering mechanics. What are the subjects that we have to involved in this structural analysis is mainly it is based on the engineering mechanics and the mechanics of solids, laboratory research, and then model and prototype testing of the mechanisms we had to learn here, and then some experience and engineering judgment we will see here. The basic methods of the structural analysis are flexibility and stiffness methods that we had to learn in structural analysis too. The flexibility method is also called as the force method and the compatibility method. Stiffness method is also called as the displacement method and equilibrium method. These two differences between the flexibility and stiffness is, stiffness method will be based on the displacement method we had to observe here, and then based on the displacement loads we had to solve the stiffness method. In flexibility method we will observe only the force method and the compatibility of that method by using the different categories, by using the matrix method that we had to observe here in the flexibility method. Now we'll see one by one what is the main idealizations and then some assumptions of the structural analysis. Okay. The following idealizations and assumptions are made here during the analysis. First one is the materials, whatever the materials we are assumed as to be elastic here. Materials are assumed to be elastic, first assumption. Second assumption is materials are assumed to be homogeneous and isotropic here. Homogeneous materials, that means it refers the identical particles that exist throughout the material. The isotropic materials that refers the identical properties in all the directions, in all the particles of the material. That is nothing but for any material we have to think that there will be a homogeneous material, that will be all particles will be exist throughout the material. It will be isotropic, that identical properties will be there in all the directions about that particular material we have to observe here. That is the second assumption. First assumption is material are assumed to be elastic. Second assumption is there will be homogeneous and isotropic materials. And the third one is stress-strain relation is linear here. If you observe that by using the mild steel, if you observe, there will be a load will be acting on that. There will be stress strain curve will be there, but here we are assuming that the stress strain curve is a linear. Stress strain relation is linear here. Okay. The fourth assumption is a body is assumed to be solid continuous, and the method of the superposition is valid for smaller displacements. These are all the main five assumptions that we have to consider here. Next one is the principle of superposition. The principle of superposition may be stated that the deflection at a given point in a structure, it will be produced by several loads that are acting simultaneously on the structure can be found by superimposing and then superposing deflections at the same point. They will be produced by the loads acting individually. And the sixth one is the Saint Vincent's apparatus and Saint Vincent's principle is valid here. Saint Vincent's principle is valid here. These are all the main assumptions that has to be taken for our structural analysis. In our GATE exams, computer exams, how they will ask this type of questions means they will ask you in structural analysis, the main assumption is whether the materials are in assumed as elastic or not. Like that they will ask. Or otherwise, the stress strain curve will be a curved position or curvilinear position or linear position. Like that they will give choose the correct answer. Okay. But here, according to our structural analysis, the main assumption is the stress strain curve will be a linear. Okay, that is hard to remember. Next one is classification of structures. The classification of structures here you can observe that based on the physical representation of the structures may be classified as three types. First one is the skeleton, that is a framed structure, skeletal structure. Second one is the surface structure, and the third one is the solid structure. Now we'll see one by one what is meant by skeleton or framed structure, and the second one is what is meant by solid structure, and the third one is how the structure will be a total full whatever nowadays we are observing that for all the first we observe the skeleton, next one is the solid, and the third one is the second one is the surface, and the third one is the solid. Then now we'll see one by one. Skeleton structures is nothing but is one of which it is represented by the lines, positions, certain rigidly properties, example portal frames and trusses, that all whatever the horizontal and vertical and inclined members that we had to observe, that all frames will call as a skeletal structures. Surface structures is nothing but it is one of which it is represented by the surface positioning, certainly rigid properties. Examples are the shells, that slabs, walls, this all will call as the surface structures. And the solid structures is nothing but the solid structure is one which can be neither be represented by the lines nor by the surfaces like earth dams, massive structures, some foundations, that all will be comes under solid structures. Now we'll see the classification of each and every classification of the structure. First we'll see classification of the skeleton or framed structures. This skeleton or framed structure is again divided into four types: pin jointed plane frames, pin jointed space frames, rigid jointed plane frames, and rigid jointed space frames. These all will solve in structural analysis 1 and 2, that will be in problematically. Simultaneously, these all method skeletal problems as framed structures will be solved in StatPro also. Okay, now we'll see one by one. Pin jointed plane frames. The members are connected by means of pin joints, and all members lie in same plane. These members carry axial forces only. This is one of the types of the pin jointed plane frame. In one plane, there will be all forces will be jointed at one point, and then they will be carry the axial forces here. Second method is nothing but the pin jointed space frames. Here in pin jointed space frames, the members are connected by means of pin joints, and all the members do not lie in the same plane. The members carry axial forces only here. That is the second method, that is a pin jointed frame, pin jointed space frame. And the third one is a rigid jointed plane frame. Members are connected by means of a rigid joint, so that the angles between the members meeting a joint, it will remain the same, and all the members lay in a same plane. These members carry axial forces, shear forces, and bending moments. This whatever we are solving by using in our problem, that are all the rigid jointed plane frames. The last one is the rigid jointed space frames. The members are connected by means of the rigid joint so that the angles between the members meeting at a point and then remain the meeting at a joint and then remain same, and all the members do not lay in the same plane. That means if you take one whatever one plane, in that plane there will be all joints will not be meet at one point here. The members it carries the axial forces, shear forces, bending and twisting moment will be observed here in this condition. This is one of the another method that you have to observe here. Next one is based on the solid structure, that is the surface structure. Based on the analysis of the structure, structures can be divided into two types again. There will be statically determined structure and the statically indeterminate structure. For our GATE exam, it is very, very important. What is meant by determined structure and what is meant by indeterminate structure? First of all, you have to know main difference between the determined and indeterminate structures. Okay. Statically determined structures, these are all the structures, those which are analyzed by using the equilibrium conditions. What are the equilibrium conditions? The equilibrium conditions are summation of horizontal force and vertical force and moment equal to 0. Sigma x equal to 0, sigma y equal to 0 and sigma m equal to 0. If these conditions will obey, then this will be called as a statically determined structure. Examples is simple supported beams, cantilever beams, two-hinged arches like this. These are all the determined structure. Now we'll see what is meant by statically indeterminate structures. These are those which cannot be analyzed by using the basic equilibrium condition along such sigma fx equal to 0, fy equal to 0 and m equal to 0. But the number of unknown forces that has to be observed here are the some reactions will be exceeding the equilibrium conditions. That exceeding equilibrium equations is called as a degree of indeterminacy. Examples is proper cantilever. What is meant by proper cantilever means for a cantilever, if you observe one end is fixed, another end is free. That one end is fixed is three conditions will obey the law. That will be statically determined structure. Proper cantilever is wherever the another end is free, in that area we are applying one support there. There will be more one reaction will be added here. That type of structures will call as the indeterminate structures. Okay, and then some continuous beams, two-hinged arches, these are all we will call as a statically indeterminate structure, where Fx is the algebraic sum of the components of all the forces, including the supports, reactions in x direction. And then sigma Fy we will call as the algebraic sum of the components of all forces, including support reactions in y direction. Sigma m is nothing but the algebraic sum of the moments of all forces about the reference point. That we will call as the summation of the moments. Okay. If these three will be equal to 0, then it will be called as the statical equilibrium condition. Sigma x equal to 0, sigma y equal to 0, and sigma m equal to 0. Next condition, we'll see what are the types of indeterminacy. There are two types of indeterminacy now. One is statically indeterminacy, another one is kinematic indeterminacy. Here first we'll see what is meant by static indeterminacy. Static indeterminacy, it refers the number of additional equations that will be required here over the static equilibrium conditions. If to analyze the statically indeterminate structure, we have to observe here the determinate structure, statically indeterminate structure is taken as ds, and then that must be equals to DSE, that is externally applied loads, external indeterminacy, plus DSI. SI is nothing but the internally applied forces, that will be whatever the loads that will be applied internally, minus number of releases, that is the reactions that you have to observe here. DSC is nothing but the external reactions that has to be applied for a plane frame 3, for a space frame it is 6, like that you have to take in here. DSI is nothing but the internal frames, you have to observe the formula. DS is nothing but the degree of statically indeterminacy equals to degree of statically indeterminacy external plus degree of statical internal minus number of releases. Okay, that statically releases of the internal members will be m equals to 2j minus 3 or m minus 2j minus 3, that will be for pin jointed plane frames. M minus 2j minus 3 for pin jointed space frame, both are same formula. Another one is 3C, that is for rigid jointed planes, plane frames. 6C for rigid jointed space frames. Okay. Where here R is nothing but the number of reactions, that is M equals to 2J minus 3, like that we had to take here. That R is nothing but the number of reactions, M is the number of members, J is the number of joints, where C is nothing but number of curves that we have to observe here. And the required for obtaining an open configuration here, that is there will be no closed boxes we have to observe here. The number of releases is nothing but the whatever the number of additional equations that has to be developed due to the internal hinge. And then n minus 1, where n is the number of members meeting at the internal hinge. These all will be followed under the given diagram, whether it will be a hinged one or a supported one, like that. Based on that, we have to find whether it is statically determined or statically indeterminate structure. Now we'll see one by one with the formulas and with figures. Next, we'll go for the kinematic indeterminacy. It refers to the number of independent components of joints that will be displacement with respect to the specified set of axes. If the displacement components of structure cannot be determined here by compatibility, some equations alone is said to be kinematic indeterminacy. The number of unknowns and then displacement exceeds the compatibility equation. That compatibility equilibrium equations is nothing but the normal summation of our equilibrium equations. More than that equations, then it is called as the kinematic indeterminacy. That our formula is for kinematic indeterminacy equals to Nj minus C, where N is the number of joints or number of displacements that has to be observed. C is the constrained displacement or reaction component. For each and every pin jointed plane frames, it is 2. For pin jointed space frames, it is 3. Like that, we had to consider according to our structural analysis. And rigid jointed plane frames is 3. That is 2 transections will be observed and 1 rotation will have to observe here. For a rigid jointed space frame, 6 will be there, 3 transactions and 3 rotations. The degree of freedom of that internal hinge is n plus 2, and then number of members meeting at the internal hinge also had to observe here in this condition to provide the hinges. Now we'll see what is meant by stable structure and what is meant by unstable structure here. First of all, you have to know what is meant by structures now. The next one is how the structures is divided into, how the structures are classified. There will be frames and then solid and then surface, and then again frames is divided into depends upon the truss. It will be a kinetics or static. Again, it will be a statically determined structure or statically indeterminate structure. In that, again, we will observe what is kinematic indeterminacy and then what is meant by static indeterminacy. Based on the formulas, M equals to 2J minus 3, and the another formula is D equals to DSI plus DSE, that is the external indeterminacy plus internal indeterminacy minus number of reactions. If that both are equal to 0, then it will be a statically determined. If both are not equal to 0, there will be 1 or 2, then it will be degree of freedom will be 1 or 2, like that we will observe. Okay, now we'll see whether it will be a structure will be a stable structure or unstable structure. First of all, you have to know what is meant by stable structure. All the physical bodies that deform when subjected to loads. However, the deformation in engineering structures is so small that their effect on the equilibrium state of the structure can be neglected here. When the structure offers a significant resistance to its change of shape, and its type of structure is called as a stable structure. That is nothing but, if suppose if we are taking one single room, there will be some load is acting on that one. If there will be more than whatever the design, more than that also it will offer the resistance, then it will not change its shape. It will be in a stable position. Then it is called as a stable structure. That means if you are designed for 100 newtons of load or 100 kilonewtons of load, but there will be more than that also, it will be in the form of same correct position. It won't be any changes of the shape. Then it will be a stable condition. Okay. Next we see what is meant by unstable structure. Unstable structure is nothing but when a structure does not offer a significant resistance to its change of shape. It is called unstable structure. There are three types of unstable structures as overall instability, local instability, and external instability. Here, if you observe the diagrams, these are all the three types of instability structure diagrams. First one is overall instability. That is, there will be two loads or two supports will be there, but the load is acting at one end. Automatically, the total building, total frame will be overall instability will be occurred here. Local instability is nothing but there will be three joints or continuous beam is there. For one continuous one side support, they will kind of observe the same loads will be applied here. Due to that also, internally there will be local instability has to be developed here. External instability is nothing but there will be due to some wind forces, some imposed forces that has to be observed. Simultaneously, here you can observe the external instability forces. This is one of the methods. These are three methods. Now we'll see, already we know for each and every support what are the reaction components, how many reaction components will be there, what are the degree of freedom. If you take the fixed one, there will be three reactions will be there, sigma h equal to 0, sigma v equal to 0, and sigma m equal to 0. That will be the three equations. No, there will be no degree of freedom, that is 0 degree of freedom. If you consider the pin jointed structure, pin jointed or hinged one, there will be only 2, and the degree of freedom is 1. Why it is 1 means our equilibrium conditions are 3. 3 minus 3 is first one 0. Second one is 3 equations minus 2 reactions equals to will get the 1 degree of freedom. Okay, next we'll consider for the roller support. For a roller, it is only 1 reaction will be there, and our equilibrium equations are 3. 3 minus 1 equals to will get the 2 degree of freedom. This is one of the conditions that you have to observe for a normal support conditions for a joint, and then based on that you have to find the reactions and then reaction components and then degree of freedom. If suppose it is a free end, if free end means there is a no support, there will be no reaction, and then that reactions will be 0 here, but degree of freedom will be 3 here. Why means there will be 0 minus 3 that equals to 3 equations, 3 degree of freedom. These are all the main basics of the structural analysis. Now we'll go for the next topic. This is one of the main important topic more. You had to listen and then you had to prepare for this basics in structural analysis. What we've seen up to now is first what is meant by structures, and then how the structures are classified, and then how we had to find the degree of indeterminacy and then degree of determinacy. Again, how degree of indeterminacy is divided here, and then how the supports will be there, and each and every support or every joint, how many reactions are there, how many degree of freedom will be there, that we had to learn up to now. Next, we will see what is the next topic. Now we'll see what is the analysis of statically determined structures. Determined trusses. For truss, we will observe here statically determined trusses. First of all, what is meant by truss? Truss is nothing but it consists of number of members, joints that are jointed together and forms a frame. That framework which is stale against any type of the loading is called as a truss. Trusses will be again we had to divide it into 2 types. One is plain truss, another one is a space truss. Plain truss is nothing but all the members of trusses lie in one plane. That is, number of members required or statically determined plain truss is n equal to 2j minus 3. That is our formula for plain truss. If it is a space truss, all the members of the truss do not lie in one plane. They will be in different planes. The formula is no number of members that has to be required for statically determined spaces is n equals to 3j minus 6. Where j is nothing but the number of joints here. Okay, this is the main difference between statically determined structure and indeterminate structure for a trusses. Truss is again divided into 2 types. One is plain truss, another one is space truss. Again, plain truss is formula is n equal to 2j minus 3. Space truss is our formula is n equals to 3j minus 6. J is nothing but the number of joints. Based on that, you had to consider. Okay, what are the main basic assumptions here? We had to observe is all the individual members are straight here for a truss. The second assumption is all the members are connected by frictional hinges, frictionless hinges here. All the members are connected by frictionless hinges. Second point. And the third one is the external load that has to be observed here. And the support reactions act on the joints only, not on the members. What are the external loads and support reactions that will be act on the joints only? That is our second point. Now we'll see what are the analysis of plane stresses and then simultaneously an analysis of the space stresses. Analysis of plane stresses are again divided into 4 types. They will ask for gate exams now what are the different types of the plane stresses. These are the main 4. One is method of joint, method of sections, and then one is the tension coefficient method, and the fourth one is the graphical method. These 4 methods are the plane stresses method. Next, we'll see one by one what is meant by method of joint. This already we learned in engineering mechanics basics. This method is suitable when 2 unknown forces are at a joint only. This type of joint method is used, method of joint. This method is suitable when 2 unknown forces at a joint only, and then it will be worked out necessary support reactions first, and then it will choose the joint which is having maximum of 2 unknown forces, and draw the free body diagram of that joint. This one already we know. First we had to draw free body diagram of that condition, and then we had to solve for the unknown condition, for the unknown force. Okay, if you know maximum 2 unknown conditions, then you have to find that type of condition only. This is one of the method here, and then we'll find out the unknown forces, and that joint by applying the equilibrium equations here. Nandini, please mute mark. Thank you. Okay, now we'll observe here the choose the joint which is having the maximum number of 2 unknown forces that has to be drawn here by free body diagram here, and then we have to find 1 unknown forces, and then we have to solve here. And then one is now we have to resolve all the forces into 2 mutually perpendicular directions, whether it will be in opposite directions or same parallel direction that has to be observed in method of joints. And then we have to repeat the same procedure for choosing the joint to determining the unknown forces until the forces of all the members are determined. Actually, this method of joints, once you have to solve the problem, then it will be easy for you. Method of joint is nothing but, suppose if you are taking one triangle, there will be one load is acting at center at a middle point. Simultaneously, that load will be carrying over to the horizontal and vertical position. There will be 2 unknown forces or 1 unknown forces that has to be applied by taking the free body diagram. This is one of the methods that you have to observe here. Next one is the method of section. Method of section is nothing but this method is suitable when the force is limited number of members that has to be found, and then it is suitable even there are 3 unknown forces are there. This type of method of section is useful. Method of joint, there you have to take only the joint, and then there will be maximum of 2 forces that has to 2 unknown forces. You have to consider the 2 unknown forces. But here method of section, you have to cut the truss, and then you have to take the 2 parts of that section. Okay. By passing through which the member has to be considered here, and then choose one of the 2 parts of the trusses, and then you have to draw the free body diagram here. And then we have to find out the unknown forces, that the section of that forces by applying the equilibrium equations here in the method of section. And then we have to repeat the same procedure until the forces in the required members are determined. Here we have to note that the section should be drawn in such a way that not more than 3 members in which the forces are to be worked out or cut. Suppose if you are taking the 2 triangles or meet at one point, whenever we are cutting the section, only 3 members has to be the unknown forces you have to observe here. That is one of the second method. Now we'll see the third one, members that carry 0 force. If 3 forces are acting at a joint and 2 of them are along the same line of action, then the third force at the joint should be 0. If both are in same direction, if both are in opposite direction along the same line, then the whatever the third force will be 0 here. That we have to observe. Next one is if 2 forces acting at a joint, then the force of that equilibrium of joint These two forces should be along the same time, same straight line. It will be equal in magnitude and opposite in direction. Otherwise, they must be zero. It is one of the third condition that members carry zero force. These are the total three methods I had observed here. And the last one is the graphical method. Here in this graphical method, we had to draw the figures, and then we had to explain clearly about the method of joint and method of sections, and then method of zero section by graphically, and then we had to explain clearly here in this structural analysis in this part. Okay, this is only the main introduction of determinant and indeterminate, and then trusses. Okay. Next class we will say about the arches, and then slope deflection method, moment distribution method, and then some stiffness and flexibility method we will see. In today's class we will see some more problems about this, whatever the structural analysis we had to learn here. Now we will share you some problems. Okay, here you can observe some type of objective questions that how they will ask. A structure it should pass us through whether it will be strength and stiffness, and then ductility, and then instability, and then proper load method that had to consider. The dead loads or will be a static or a fixed one that had to know about the different points here. If you observe each and every condition, here you can observe some answers will be there. I will share this notes for you to solve some more questions. Again, here you can observe this condition for the statically determined or indeterminate. Here also observe this diagram where it is very important one. The degree of static indeterminacy of a rigidly jointed frame in a horizontal plane. This one is a horizontal plane and is subjected to some vertical loads only as shown in figure. Here, how we had to find the degree of statically indeterminacy. How we will find the degree of statically indeterminacy is according to our number of reactions. We had to find the degree of static indeterminacy. How we will find that one? First of all, see the solution. If a given loading pattern may be treated as a space frame, then hence there is no reactions at each rigid end, rigid support. If it is considered as a space frame, there will be only 6 joints will be there, 6 frames we have to observe that one. If total number of reactions are 2, only at this condition, each clipped by the rigid wall, that clipping will be two hinges, that is multiplied with the space frames, that number of reactions of the rigid frame, not no. It will be a number of reactions, that will be a 6. Then we have to consider as the total number of reactions will be 2 hinges multiplied by the 6 number of space frames. Then we will get the 12. That is the 12 static equilibrium equations. That static equilibrium equations is nothing but how we have to consider this one is, it is a fixed first. You have to think 3 plus 3. Equilibrium conditions are 6. Again, you have to consider that 6 minus this 12. 12, how you get the 12 means total number of reactions. Total number of reactions are 2 times into 6. That will be 12 minus 6 here. Our answer will be for this type of problem, you have to consider, then it will be 6. Next, you will go for the rigid frame having the 2 hinged ones. The degree of static indeterminacy of a rigid frame having 2 internal hinges. Here you can observe clearly the 2 internal hinges, and then another one is 3. First, observe the external one. This one be hinged is 2, roller is 1, another roller is 1. That is 2 plus 1 plus 1, 4. Statically indeterminate. So you have to observe here. That is 4 minus 3 equilibrium equations. That is external formula. 4 is according to our given diagram. Hinge is 2, roller is 1, another one is roller, that is 1. 4 minus 3 equilibrium conditions, our degree of statically indeterminacy externally is 4 minus 3, that equals to 1. Internally, if you observe the internal conditions, that is 3 members into 2 joints or 3 joints into 2 members. 1, 2, 3 joints will be there and then 2 members will be there. 3 into 2, 6. And the releases will be 1 plus 1. That is the 2 we had observed here. That releases is nothing but wherever you had to remove one condition. If you want release or cut, here you can observe total 1, 2, 3, 4, 5, 6, 7 more total here. But we are considering only this condition. Seven minus releases will be 2. Releases is nothing but wherever you are cutting the equilibrium equations, that releases will be 2 here. Depending upon that, 7 minus 2 here we are getting the 5. Degree of statical indeterminacy. That is external minus internal, like that you have to calculate, or otherwise you have to simply take external is 4 minus 3, that is 1. Internal it is 7 minus 3, that will be 4. 4 plus 1 is 5. Directly you can write like that also. That is also one tip. Simple formula, external indeterminacy formula is you have to take the, according to the support, 2 plus 1 plus 1, 4. 4 minus 1 is 3. 4 minus 3 is 1. 1 indeterminacy is there. If you take internally, number of members you have to calculate 1, 2, 3, 4, 5, 6, 7. 7 minus 3 equilibrium conditions are there. 7 minus 3 is 4. You will get the 4 unknowns. Here, internally 4 unknowns and externally 1 unknown. Total you have to add, then you will get the 5 unknowns. That is one of the formula. Okay. A beam is fixed at the ends and the support and subjected to lateral movement, lateral loads, and the lateral loads only is statically indeterminate. Then the statically indeterminacy of that one is 2 here. Here you can observe here 2 sides of the support. That is the 3 plus 3, 6. 6 minus 3. It is 3, and then there will be internal member is 1. That has to be checked here. Total number of reactions and then total number of supports. Here it is, you have to observe this one is not a fixed one, 2 hinges, then it will be 4. 4 minus 3 equals to 1. Then that 1 will be added to the under condition. Degree of statically determined equals to degree of internal indeterminacy plus external indeterminacy. Externally it is 2, internally it is 0. Externally how it is 2 means there will be 6 numbers will be there. Directly will solve the problem better instead of answer solution. If it is a fixed one, 2 ends are fixed, 2 supports are fixed one, then 2 supports are fixed means 6 minus what are the equilibrium conditions will be 3. What are the unreleased one is the 1. Then we have to take as that 3 minus 1 equals to 2. That is one of the main methods that has to be solved in statically indeterminate structures. And then statically determined structures. These are the number of formulas that has to be obtained here. Based on that, we have to calculate number of problems. Okay. In next class, we will see, tomorrow class, we will see about the arches and then structural movement distribution. Some more basics we will see in the next class. Okay, students, thank you for attending the class and then thank you for giving this opportunity. Thank you, ma'am.